Okay, so question 3. Given the following chemical bonds, potassium fluoride, fluorine fluorine, bromine fluorine, chlorine fluorine, and calcium fluorine, what is the correct order in terms of increasing covalent character? Okay, so typically we want to look at the difference in electronegativity. So each atom has certain electronegativity value. And when we take the difference between the two of them, which can be shown as delta En, this can tell us how covalent the chemical bond is. So delta electronegativity can just be found by taking the difference between electronegativity of one and the electronegativity of the other. So notice that we're only interested in the absolute value. So if we were to get a negative difference, we would just look at the positive value of that number. Okay, so first let's just find the electronegativity values of all of the different atoms that we're looking for. So we're looking for potassium, fluorine, bromine, chlorine, and calcium. So I'll just search here. Electronegativity chart. Okay, so if we look at the value for potassium, it is found here, atomic number 19. It has an electronegativity value of 0.8. Fluorine is at the top right, and its electronegativity value is 4.0. Bromine is below it, 2.8. Fluorine is above bromine, 3.0. And calcium is found on the left side. The electronegativity value is 1.0. Okay, so now that I have all my electronegativity values, I can find the delta En value for all of the different bonds. Okay, so I'll just make a chart showing the bond and then the corresponding delta En value. So first we have potassium and fluorine. Its delta En value is just 4 minus 0.8, which is just 3.2. Next is just a fluorine-fluorine bond. So since they are the same atom, they would just have a delta En value of 0. Next is a bromine-fluorine bond. So it's just 4 minus 2.8. So it's just 1.2. Next, for the chlorine-fluorine bond, it's 4 minus 3, so it's just 1. And then lastly, a calcium fluorine bond has a difference of 4 minus 1, so it's 3.0. Okay, so when we want to look at how covalent this bond is, when we have a greater delta electronegativity value, the more ionic our bond is. So now we just kind of have to rank from most, no, not ionic, but most covalent character to the least. So the highest delta En value was the potassium fluorine bond. So next is the calcium fluorine bond. And then bromine fluorine. And then chlorine fluorine. And then the one that has the least covalent character is the fluorine fluorine. Okay, so let's see what the junior tutor said. Covalent character can be determined by calculating for the absolute difference of electronegativities of the atoms involved in the bond. Mathematically, this would be delta En is equal to the electronegativity value of one minus the electronegativity value of another. Recall that electronegativity is the ability of an atom to attract an electron towards itself in a chemical bond. Generally, the higher the difference, the higher is its ionic character, thus the lowest its covalent character. The electronegativity values of the atoms in the pool of chemical bonds given are shown in Table 1. So here they also just have the electronegativity values of all of their atoms. And then the absolute difference of the electronegativity of the atoms in the chemical bond from the pool are shown in Table 2. Absolute difference of the electronegativity of the atoms in the given chemical bond. So then they also just have all the differences between them. Using the values computed in Table 2, we can now rank them in increasing covalent character. The correct order is potassium fluorine, calcium, bromine, the chlorine, and then fluorine fluorine. So this got the two mixed. So when you have a bond that is least covalent, that means it is more ionic. And when you have a bond that is most covalent, that means it is less ionic. Okay, so this solution is correct.